Good day, students. Welcome to our lesson this week for General Mathematics. Today we're going to have operation on functions. We will also discuss composite functions. For the operation on functions, let f and g be functions of the variable x. So the sum function f plus g is represented by f plus g of x equals f of x plus g of x. For the difference function f minus g, it will be illustrated as f minus g of x equals f of x minus g of x. For the product function f times g or fg, it will be shown as fg of x equals f of x times g of x. For the quotient function f over g or f divided by g, it will be f divided by g of x equals f of x over g of x, where g of x is not equal to 0. For composite functions, f of g of x is equal to f of g of x. So g of x became the domain of f. So take note that f of g of x is different from g minus f of x. Okay? Again, f minus g of x is different from g minus f of x because g minus f of x is equal to g of x minus f of x because the subtraction operation is not commutative. It also same like g over f of x, it is different from f over g of x because same as the operation subtraction, the operation division is not commutative. So g over f of x is equal to g of x over f of x, where f of x is not equal to 0, the denominator, to avoid undefined result. And g of f of x is equal to g of f of x, where f of x is the domain of g. So it is different from f of g of x. So later on our examples, you're gonna see why it is different. So for example, find the following given that f of x equals x plus 1 and g of x equals x squared minus x minus 2. So let's find number 1, f plus g of x, number 2, f minus g of x, number 3, f times g of x, number 4, f over g of x, number 5, f of g of x. We also find number 6, g over f of x, number 7, g of f of x, number 8, g minus f of x, number 9, f plus g of 3, and number 10, f times g of negative 4. Okay? So let's start with number 1, f plus g of x equals f of x plus g of x. So let us just add f of x and g of x. F of x is x plus 1, g of x is x squared minus x minus 2. So our solution will become f plus g of x equals x plus 1 plus x squared minus x minus 2. So put a parenthesis first, okay? To indicate that those two came from two different functions such as f of x and g of x. Then remove the parenthesis. So it will become f plus g of x equals x plus 1 plus x squared minus x minus 2. Then combine the like terms. So write our algebra expression in descending order. When I say descending order, it means that you are going to write the term with a higher degree first, followed by the term with the next degree, and so on. So in this case, we are going to have f plus g of x equals x squared plus x minus x plus 1 minus 2. So as you can see, the like terms are written beside each other so that we can easily combine it. So it will become f plus g of x equals x squared minus 1. Because x minus x is 0, 1 minus 2 is negative 1, so we're going to have x squared minus 1 here. So this is our answer. F plus g of x is equal to x squared minus 1. Any question? Okay. Will it get the same answer if we're going to express it as g plus f of x? The answer is yes. G plus f of x will get the same answer because the operation addition is commutative. Okay. Number 2, let's get f minus g of x. So it is equal to f of x minus g of x. Substitute the values or uh, the f of x and the g of x. So this is the, now you can see the importance of the parenthesis. Why? So f of x is x plus 1. G of x is x squared minus x minus 2. So there's a subtraction symbol outside x squared minus x minus 2. So if you remove the parenthesis, it will become f minus g of x equals x plus 1 minus x squared plus x plus 2. So see, the operation symbol, the subtraction symbol minus or negative was distributed to all the terms inside x squared minus x minus 2. Negative times x squared or negative 1 times x squared is negative x squared. Negative times negative is positive. That's why it became positive x. Negative times negative is also positive. That's why it became positive 2. So now we have f minus g of x equals x plus 1 minus x squared plus x plus 2. Then write the like terms together, arrange the terms in descending order. We're going to have f minus g of x equals negative x squared plus x plus x plus 1 plus 2. Then just combine the like terms. It will become f minus g of x equals negative x squared plus 2x minus 3. And that's our final answer. Number 3, f times g of x equals f of x times g of x. So multiply f of x and g of x. We're going to have here f g of x equals x plus 1 times x squared minus x minus 2. So just apply multiplication of polynomial or multiplication of algebra expression. So you're going to have this. So take a look at that. X times x squared is x cubed. X times negative x is negative x squared. X times negative 2 is negative 2x. 1 times x squared is x squared. 1 times negative x is negative x. 1 times negative 2 is negative 2. That's why we have here fg of x equals x cubed minus x squared minus 2x plus x squared minus x minus 2. Write the like terms beside each other, arrange the terms in descending order. We're going to have f g of x equals x cubed minus x squared plus x squared minus 2x minus x minus 2. Combine the like terms, we're going to get f g of x equals x squared minus 3x minus 2. And that's our answer. For f over g of x equals f of x divided by g of x, again, just substitute the f of x and g of x. So we're going to have f over g of x equals x plus 1 over x squared minus x minus 2. So actually, this can already be our answer. But just in case there could be common factors or the numerator or the denominator can be factorable. So try to simplify the expression. In this case, I gave an example which can be simplified. So as you can see, the denominator can be factored. So let us factor the denominator. So it will become f of g of x equals x plus 1 over x minus 2 times x plus 1. So review your factoring skills. If you have questions regarding factoring of algebra expressions, just message me. So, but I hope you already know how to do factoring. It is expected already because you are already in senior high school. Anyway, let's continue. So it will the x plus 1 are the common factors, so it will be eliminated, or you're using the term cancelled, but we're doing that because they are common factors. Okay, so we're going to have f of g of x equals 1 over x minus 2, but there's a condition: x must not be equal to 2 and x must not be equal also to -1 to avoid undefined results. Okay, because our denominator has factors x minus 2 and x plus 1. That's why x must not be equal to 2 and it must not be equal also to -1. Okay, I hope you got that concept. So that's our answer. Okay, for number 5, let's have f of g of x. Now, since g of x is the domain of f of x, so we're going to use f of x equals x plus 1. Then f of g of x, so substitute g of x to x. So we're going to have f of g of x equals x squared minus x minus 2 plus 1. So as you can see, the x was changed into x squared minus x minus 2, which came from g of x. Then just simplify the expression. F of g of x equals x squared minus x minus 2 plus 1. So just combine the like terms. So f of g of x is equal to x squared minus x minus 1. And this is already our answer. So that's very easy. I hope you understood the process. For number 6 now. So earlier we have obtained f over g of x. Now let's try to get g over f of x. And let's see if, like what I've said before, it will lead to different answers. So let's see if it will be different. So g divided by f of x is equal to g of x over f of x. So substitute the f of x, the g of x and f of x respectively. So we're going to have g over f of x equals x squared minus x minus 2 all over x plus 1. Factor the numerator because we already know that it is factorable. So g over f of x is equal to x minus 2 times x plus 1 all over x plus 1. X plus 1 is the common factor, so let us eliminate it to simplify the expression. So our answer will become g over f of x equals x minus 2. Okay, for number 7, let's try to look for g of f of x, composite function. So since f of x is the domain of g of x, we're going to use g of x. So change the x of g of x into x plus 1, which came from f of x. So g of f of x is equal to x plus 1 square minus x plus 1 minus 2. So take a look at that. The x became x plus 1. So let's continue. So it will become g of f of x equals x squared plus 2x plus 1. So by squaring a binomial, then followed by negative x minus 1. So because the negative symbol was distributed, then followed by minus 2. Then it will become g of f of x is equal to x squared plus 2x minus x plus 1 minus 1 minus 2. So g of f of x is equal to x squared plus x minus 2. So as you can see, it is different from f of g of x. Compare it. Okay. For number 8, g minus f of x. So it is equal to g of x minus f of x. So substitute the values of g of x and f of x so that you can have this g minus f of x is equal to x squared minus x minus 2 minus x plus 1. So like what I've said before, express g of x and f of x inside the parentheses first because it's very important, especially in subtraction, because there could be changes in signs of the terms. Okay, so take note of that. So like this one. So in g of x there will be no changes, but in f of x, since there's a subtraction symbol or negative symbol outside, so it will be distributed. That's why we're going to have g minus f of x equals x squared minus x minus 2 minus x minus 1. Then just simplify this. We're going to have g minus f of x equals x squared minus x minus x minus 2 minus 1. Combine the like terms, we're going to have g minus f of x equals x squared minus 2x minus 3. And that's our answer. And that is different from what we've got compared to g or f minus g of x. Okay, compare it. For number 9, so we have obtained that f plus g of x is equal to x squared minus 1. But so what will be the value of f plus g of 3? Okay, so since we have obtained already the f plus g of x, which is x squared minus 1, so we will just substitute the value of x, which is 3. So that will become x plus g of 3 equals 3 squared minus 1. F plus g of 3 is equal to 9 minus 1. F plus g of 3 is equal to 8. And that's our answer. We actually use a shortcut here, but you can actually, if you want, add f of x and g of x first. Or if you want, you can write the entire sum of x plus 1 and x squared minus x minus 2, then just substitute x. Still, you're going to arrive at the same answer. For number 10, just like the previous item, we have already obtained the value of fg of x, which is x squared minus 3x minus 2. So if x is equal to negative 4, what is f times g of x? So we're going to have this f times g of negative 4 is equal to negative 4 squared minus 3 times negative 4 minus 2. So f times g of negative 4 is equal to 16 plus 12 minus 2. So negative 4 squared is 16, negative 3 times negative 4 is positive 12. That's why. So we're going to have f times g of negative 4 equals 26. And this is our answer. We also use a shortcut here. Okay? So now, let's have a practice. So if f of x is equal to 3x minus 2 and g of x is equal to x squared plus 3x minus 3, find f plus g of x. Okay, pause the video first. Then after solving, play it again and let's see if we're going to have the same answer. Okay, I guess you're done. So f plus g of x is equal to f of x plus g of x. So it is equal to 3x minus 2 plus x squared plus 2x minus 3. So remove the parentheses. 3x minus 2 plus x squared plus 2x minus 3. So x squared plus 3x plus 2x minus 2 minus 3. So your answer will be f plus g of x is equal to x squared plus 5x minus 5. Did you get the correct answer? Very good. Next. Let f of x equals x squared minus 5 and g of x equals 5x plus 4. Find f minus g of x. Okay, pause the video now. Okay, so Now you unpost the video or you play the video, and let's see if you have the same answer, if you got it right. Solution: f minus g of x equals f of x minus g of x. So x squared minus 5 minus 5x plus 4. So it will become x squared minus 5 minus 5x minus 4. Very good. X squared minus 5x minus 5 minus 4. So f minus g of x is equal to x squared minus 5x minus 9. Congratulations for getting the correct answer. Okay, for product of functions, so if f of x is equal to 3x minus 2 and g of x is equal to x squared plus 2x minus 3, find f times g of x. Okay. Now let's see if we got the same answer. F times g of x is equal to 3x minus 2 times x squared plus 2x minus 3. So in terms of multiplication of algebra expressions, we have our own methods or strategies. Okay. But if we are going to execute our solution properly, we're going to arrive at the correct answer. So in this case, 3x and negative 2 was multiplied to x squared plus 2x minus 3 by distributive property. So that's why it will lead to 3x cubed plus 6x squared minus 9x minus 2x squared minus 4x plus 6. Then let's combine the like terms, or write the like terms together, arrange it in descending order. So that's why it became 3x cubed plus 6x squared minus 2x squared minus x minus 4x plus 6. So your answer is f times g of x is equal to 3x cubed plus 4x squared minus 13x plus 6. You got the correct answer also? Very good. I'm very proud of you. Okay. This time, let's have f divided by g of x. If f of x is equal to x plus 3 and g of x is equal to x squared plus 2x minus 3, find f over g of x. Now, pause the video and solve. Okay, guess you're done because you play the video again. Let's see if we have the same solution. So f divided by g of x equal to x plus 3 over x squared plus 2x minus 3. So happen that the denominator is factorable. So f of g of x, f divided by g of x equal to x plus 3 over x, or all over x minus 1 times x plus 3. So x plus 3 is a common factor, so that's why we have here f of g of x equals 1 over x minus 1. Where x is not equal to negative 3 and x is not equal to 1. So to avoid an undefined answer. Okay, so this is our answer. Let's have another one. If f of x is equal to x squared plus x minus 20 and g of x equal to x minus 4, find f over g of x. Okay, for the solution, f over g of x equal to x squared plus x minus 20 all over x minus 4. The numerator is factorable, so it will become f over g of x equals x plus 5 times x minus 4 all over x minus 4. So happen that x minus 4 is a common factor, so it will be cancelled or eliminated. So it will become f over g of x equals x plus 5. So x must not be equal to 4 to avoid an undefined result. So this is our answer. Oh, let's have a practice for composite functions. Given f of x equals 4x minus 5 and g of x equals x squared plus 4, find f of g of x. You're done? Okay, let's see. So f of x is equal to 4x minus 5 because in this case g of x is the domain of f of x. So f of g of x is equal to 4 of g of x minus 5. G of x is x squared plus 4. That's why it became 4 times x squared plus 4 minus 5. So simplifying it, you're going to arrive at 4x squared plus 11. So f of g of x is equal to 4x squared plus 11. Very good. So for the exercises, you answer this. Find the following given that f of x is equal to x squared plus 3x minus 10 and g of x is equal to x plus 5. Okay? So you're going to have 15 solutions here. Good luck. I know you can do it. Always remember, class, that if you want to master your mathematical skills, do mathematics to learn mathematics. Practice, improve, and stay curious. Keep safe, stay healthy. God bless everyone. See you next week. By the way, thank you very much for listening. I hope you learned something.